Alrighty guys, we're going to be doing half-life problems. I'm going to do problems 16 and 17 with you. It's going to be on your review sheet. It's right down here, 16 and 17. I'm going to do both of those with you guys. So for number 16 first, the first thing we always do is we pull out the time it takes for it to have a half-life, and then we pull out our ending piece of information. So reading the problem, it says the half-life of polonium-210 is about 138.4 days. That right there is your half-life length of time. So we're going to write that right here. It's going to be 138.4, and we say it's days. Okay? And then it says, how many milligrams of polonium-210 remain after 415.2 days if you start with 2.0 milligrams of the isotope? Okay, so first off, we have to pull out our ending time. Our ending time is 415.2 days. Once we have our half-length time and we have our end time, we can start to build our table. Our table starts off with a column for the half-length, or half-lives, a column that's labeled R, which we know stands for remaining, and then our last column is time, because we have to see how much time passes. So we always start off our chart with 0. 0 half-lives have happened, so that means that 0 time has passed. Now, you'll put one of two answers in here to start off R. If I don't give you a sample size that you start with, you're going to put a 100 right there. If I do give you a sample size like we did in this problem, then that's when you're going to put that sample size right here and start its half-life, okay? The sample size I gave you in this problem was 2.0 milligrams, so we're going to put that down. Okay? So now we're just going to build our table the way that we have in class until we hit this ending amount of time. Okay? So we're going to say 1. We say 2 divided by 2 because we're taking the half of it. So that means they're going to have 1 milligram. And the time that it takes for one half-life to happen is 138.4 days. None of these numbers match our ending place, so we're going to start another row. So we'll have 2. We say 1.0 divided by 2, and that gets us to 0.5. And then what we're going to do is we're going to add 138.4 plus 138.4. And what we're going to end up getting is 276.8 days. Let me check myself with a calculator. Sorry about that. It's 138.4 plus 138.4. 276.8 days. None of those numbers match my ending number, so I'm going to do another one. 3. 0.5 divided by 2 becomes 0.25. And then what we're going to do is we're going to add 276.8 plus the time it takes for it to go through another half-life, which is 138.4. So once we do that, we get 415.2 days. Now, one of these numbers is the number that matches my end number. So that means that we can stop and I can just go ahead and box it in. Stop and box it in. After you've boxed it in, you know that you're only going to focus on one of these 3 numbers. So we're going to look back at our problem and see what it's asking us for. It says the half-life of polonium is 210 is 138.4 days. Then it says how many milligrams of polonium. So we're going to be looking at the column in the table that has milligrams with it. And if we look, we see that this isn't it, but here is our symbol for milligrams, so we know that this is our answer, and that's what we're going to circle. So we know that after it goes through half-life, so after 415.2 days, there's only going to be about 0.25 milligrams left over of polonium-210. Now, let's do the exact same thing, except we're going to do it for number, this will be number 16. Oh, no, excuse me, 17. 17. So we're doing, we just did problem number 16. We're going to do problem number 17 now. Same thing. We have to pick out a half-life time, and we have to pick out an ending time so that we'll know when to stop our table. The first thing is that it says the half-life of cobalt-60 is 10.47 minutes. So we know that that's going to go right here. Okay? And then we know that it says how many milligrams of cobalt-60 remain after 104.7 minutes if you start with 10.0 milligrams. So our end time, we can see, it says after 104.7 minutes. So that's our end time. Okay? And then it says if I start with 10 milligrams. So I'm just going to build my table. Column for the half-lives. And then time right here and remaining right here. As always, we start with 0. So that becomes 0. That time is 0. And then we look in the problem and see if I gave you a start time or not. I gave you not a start time, but a start sample. I gave you a start sample. It's at the end of the problem. It says if you start with 10 milligrams. So that's what we're going to write right here. All right, we have to have our ending time become the number 104.7. So I'm not going to really explain it. I'm just going to start doing it and stacking on the numbers, okay? So we have 10 divided by 2 is 5 milligrams left over. And the time that passes is 10.47 minutes, okay? Then we're going to keep going. 2, 2.5, and then 10.47 plus 10.47 becomes 20.94 minutes. 3, this becomes 1.25 milligrams. We stack on 10.47 plus 20.94 because after another half-life has happened, that length of time still passes on. So we'll add those together. We always add the time column, and that becomes 31.41 minutes. Keep going. 1.25 divided by 2 becomes 0.625 mg. And then 31.41 minutes have already passed. Another half-life has happened, so we add 31.41 plus 10.47, and we get 41.88. Another half-life, 0.625 divided by 2 becomes 0.3125 mg. And then 41.88 minutes had already happened. Another half-life goes through, so we're going to tack on more time. So that means that we're going to add 41.88 plus 10.47, and you get 52.35 minutes. Another half-life happens, so that means that 0.3125 divided by 2 becomes 0.15625. Then 52.35 minutes had already happened. Another half-life happens, so that means we have to add on 10.47, and that becomes 62.82 minutes. And we just keep going like this. This becomes 0.078125. And then we add on to that column 62.82 plus 10.47, and we end up with 73.29. Keep going. 0.078125 divided by 2 becomes 0.039065 mg. And then we keep tacking on time. So 73.29 plus 10.47 becomes 83.76. We're getting closer, guys. Number 9, keep on dividing. 0.039065 divided by 2 becomes 0.0195325 milligrams. We're adding time, so 83.76 plus 10.47 becomes 94.23 minutes. And then we do another half-life, and we get this number divided by 2. So 0.0195325 divided by 2 becomes 0.009765625 milligrams. And then we say 94.23 plus 10.47 because that is the amount of time that's passed, and we've been adding on our half-life time the entire time. So we're going to add that onto there, and we're going to get 104.7 minutes. 104.7 minutes is the place that we need to end. So we box in our ending result. And then what we do is we go back to the question to see which answer would be the one that suffices for the problem. We see that it says how many milligrams of cobalt-60 remain. So that means that we're looking for the number that has the milligrams after it. So that means that right here, cobalt-60 with a half-life of 10.47 minutes will decay down to 0.009765625 milligrams in 104.7 minutes. Now you might see it like this on your test, or you might see it as just 0.00, two real numbers after the decimal place. We take the 9, we look at the 7, we look at the trailing number. The trailing number is a 6. That's bigger than 5, so that 7 doesn't stay a 7, it becomes an 8. So you could also see it like that on your test, okay?